So I'm going to start doing some evens here to just give you an idea of how to do the odds in these sections. Hopefully a lot of this is review, some of it won't be. So anyway, number 2 gives you the ordered pair 5, 10. It's giving you a set of points. It's a set notation. And then 3, -2, 4, 7, and 5, 8. And the question is, write the domain and range and state whether it's a function. Now technically I don't think they should call it the domain if it may or may not be a function, but they are. They're asking you to state the domain and range first. So the domain is all of the x's, okay? I think of the domain as the input and the range is the output. Something goes from the domain to the range. So it goes in with a math equation, it goes from x to y. So the x's are the domain and the y's are the range. So the domain here is, and this is not a line, this is these 4 points. It's not a continuous thing, okay? So the domain is 5, 3, 4, and 5. So if I list them in order, the domain is 3, 4, and 5. So maybe on day 5 you measured something, it was 10. You took a different measurement the same day and it was 8. Day 3 was -2 and day 4 was 7. So the domain is 3, 4, and 5. Okay? The range is the y values. So that's 10, -2, 7, and 8. So if you put them in order, it's -2, 7, 8, and 10.
What's the domain mean again?
It's just the starting point. It's the set of all of the numbers you start with.
Values, right?
The x values. But you could have a relation, like I could ask all of these seniors where they plan to go to college. That's a relationship. It's not a mathematical relationship, but the domain would be the seniors and the range would be the different names of the colleges. Okay, so it's the starting point and the ending point. But with numbers, the x is the domain and the y's are the range. Okay? Then it says, is it a function? Okay, here's the deal with functions. There's lots of ways to think about this. I like to say that a function is something, when you ask the question, there's only one answer. So if I say, if I'm looking at the temperature at a certain place, like on our farm, if we've got a temperature gauge, and I say, what's the temperature at 1 o'clock? Well, there's only one answer. It can't be 2 different temperatures at 1 o'clock at one place, okay? So that would be a function because there's only one answer for that. If I say, how tall is the plant? Let's say you're doing an experiment and you're testing different fertilizers. How tall is the plant on day 2? How tall is the plant on day 3? Well, there's only one answer to that. Like you go and you measure it on that day and whatever the height is, that's the answer. So you can't have 2 different answers. So an example of something that would not be a function is, what's the name of your pet? You might have 2 pets. That has 2 answers. So that's not a function. Okay? What did you have for breakfast this morning? Maybe you had 2 different things for breakfast this morning. So that's not a function. With numbers, if I say, what's the square root of 9? That's not a function because there's 2 answers to that. It could be 3 or it could be -3. Okay? What would give you the absolute value of 8? Well, a +8 and a -8 both would. So that's not a function. It's a mathematical question that has a legitimate answer, but it is not a function because there's more than one possible answer left. Okay? In a function, you're allowed to have 2 different questions to give you the same answer. For instance, on the plant thing, it might be the same height 2 or 3 different. On day 3, it might be 5 inches. On day 4, it might still be 5 inches. That's okay. That's a function. Okay? If you keep track of your weights, like if you're lifting weights and you keep track of your lifts, if you try to max out so many times, there's several different days you might have the same max. But you wouldn't say my max today is 350 and also 320. You only have one answer. But you can have the same answer more than one time. Okay? Like y equals x squared. Y equals x squared. So the function is like a box. If I input 3, I get 9. That's okay. I only get one answer. But if I input -3 into the same thing, I also get 9. That's okay. I can get the same answer. It's still a function. When I put one thing in, I need to get one answer. Mrs. Schooley had a really good analogy with the vending machine, okay? If you go out and you put your money in the vending machine, if I push the button for Pepsi, I better get a Pepsi. If I push a button, I get one thing. Now, you might have 2 different buttons that give you Pepsi. But if I push one button, I'm not going to get a Pepsi and a Dr. Pepper. Does that make sense? So it's a function because when I push one button, I get one result. So one thing gives you one result is a function. So this particular thing is not a function because 5 gives me 10 and 5 also gives me 8. I have 2 different answers to the same question. So this is not a function.
So you can't have 2 x's that are the same, they give you a different y?
Correct. Correct. Because this is, what's the partner of 5? 10. What's the partner of 5? 8. That's 2 different answers to the same question. Or if we make a...
Sorry, but you can have 1x
But I could have 6, 8. That would be okay. 5 can go to 8 and 6 can go to 8.
Okay.
But 5 can't go to 8 and 10.
Perfect.
Okay? It makes more sense when you look at it with this. This is called a mapping diagram. If I take this function and put my domain in it, 5, 3, 4, 6, and I put my range in it, -2, 7, 8, 10. Okay, 5, can't see my original points, but if 5 goes to 10, I've got an arrow going from 5 to 10. 3 goes to -2. I should have made this in a line. 4 goes to 7. 5 also goes to 8. So that's my problem. I've got 2 things coming from the same thing. And 6 goes to 8. That's okay. Okay, I can have 2 different roads going to the same place, but I cannot have 2 different roads coming from the same place. Okay? So a lot of different ways to look at it. Okay, so then they could give you an equation, like number 6. They could say g of x is equal to 1 minus x squared, and then they say x equals -1. And the question is, determine whether the given value of x is in the domain of the function. So this is confusing because this one, the domain is anything. Do you see that I could plug any number I want to in the world for x and square it and then take 1 minus that number? So if I take negative, the question is -1 in the domain? If I take -1 and put it in for x squared, I get 1, and then 1 minus 1 is 0, I get an answer. So it's weird to say, is -1 the domain of this, because this domain, like everything works in this. The domain of this function is all real numbers. So -1 is definitely going to be in the domain. It would make more sense, so this answer would be yes. It would make more sense if I said g of x is equal to the square root of x minus 3. Is x equals 10 in the domain of the function? Can I plug 10 into here and get a legitimate answer? Everybody think about that and tell me yes or no.
Yes.
Correct, because 10 minus 3 is 7, and I can find the square root of 7. It's a messy decimal, but it exists. Okay? What about x equals 1? Is that in the domain of this function?
No.
Why not?
It's imaginary.
Because it's imaginary. If I take 1, 1 minus 3 is -2, and I can't do the square root of -2. So 1 does not work in this function. So 1 can't be my starting place. What are you thinking, Kale?
I mean, you still get you can divide 2, like square root 2 and get a decimal.
No, you can't. Not -2. You can do
negative.
square root. Yeah, you can square root 2, but if I plug in 1, I get the square root of 1 minus 3, which is a square root of -2. And then I've got to do I radical 2, and so that's not on the real number, so I don't get a real answer.
So it's anything bigger than 3.
Correct. Correct. 3 or bigger, yeah, I could have 3, because I could do square root of 0, and then anything bigger than 3 would be okay. Right. Now, if you graph that, if I go to 3, 1, 2, 3, it would look like this. And so most students are better at getting domain. If I just gave you that picture and said, what's the domain? You'd be like, oh, 1, 2, 3, that's 3 to infinity. Okay? But you need to be able to do it coming from an equation also. But in that first section, they're going to give you numbers and you're going to test them. So it's a little bit easier. If I give you the equation and say, what's the domain? That's a little bit harder. Okay? Then the next one is, let me pause this video and start over.